can see that we have about 25 people who registered in our webinar. So waiting for them.
Very custom auditorium.
Yeah, it's not big audience, and so enough target group really for that people who can be interested in the reverse engineering and some our experience in our company and how we use. But honestly, to say, in our company, almost all projects, from a low-level development, from the kernel extension development to the web solution like software as a service solution, we use reverse engineering skills, and maybe it's different part of work for the each project, but we really use it. And in our company, we even have separate reverse engineering department, and exactly Anton, who is our main speaker for this webinar, the development leader and reverse engineering leader. He is a top expert in our company in reverse engineering, and he has about 15 years exactly in reverse engineering, and for the different domain of type of project, and for the forensic, for the antiviruses, and for the kernel extension, for the embedded solution, for the different protocol, for the parsers, for the undocumented formats. And during this webinar, we will have these special rules, and all attendees who are connected to this webinar will not be able to talk, but you will have the possibility to ask questions. For this, you have the special button in our webinar, question and answer. So please type your questions in this section. During our presentation, we will have the special page with questions, and I will stop and pause the speech of Anton, and I will ask and I will facilitate and this question and this process, and Anton will answer on them. And after our presentation, if we will have enough time, so I will provide the possibility to discuss if you have some questions. So if you would like, of course, I will unmute. For this, you can raise a hand. So for this, you have also special button in this Zoom functionality, and you please click on them, and I will see that you would like to discuss some question, but please do it in the end of the whole presentation. So I think we can go ahead with our webinar, and as I already introduced our main speaker of this webinar, Anton Kukoba. So our webinar will take about 50 minutes for the presentation, and after that about 10 maybe 20 minutes we will have for the discussion, for the question. So please, Anton, you can start.
Hello everyone, thank you, Claudia, for the introduction, and it's already 16 years of reverse engineering experience. So let us start. As the subtitle for my presentation reads, when innovation is not the goal of the development, and I mean by that often IT project is not something innovative. It's more custom combination of technologies and business needs which has to be implemented. So customer doesn't really asks you to be inventing. He wants you to combine some common practices, some stable technologies, and add something of his needs to solve the problem which he is trying to solve by this project. And for you, it's the problem if that you can't know all the technologies and the frameworks at the same time. And in my experience, often I had to deal with the situation where you know about 50% of the technologies which are required for the project, and it's 40 of totally unknown to me, and there is about 10% of domain-specific things which come from the client's domain. I mean, it's always some part of the project which you have to learn from the very start. And new frameworks, new operation system, new technological stack, and you have just a part of knowledge which you need to complete the task. So this gap of knowledge is affecting estimates. It also affects the development time. It will, in the end, also affect the quality of the product and the amount of bugs. In general, when it's direct engineering approach, this lack of knowledge is solved by studying the technologies and trying to research and experiment with them in order to become expert, so that further solutions and decisions are made based on the experience which you got from this research and experimentation. But if the time for the research is limited and there is actually no way to master such amount of information about the technology in the short term, and if you try to do something with this new technology and you fail, though you know that there are existing solutions on the market which are using this technology and they succeed, but you fail. So what do you do in such situation? Do you say to your customer that no, I can't do this, and just lose the opportunity to work with the new technology? So for such situations, there is last resort option. It's reverse engineering.
Anton, yeah, could you please unmute?
Yeah, I just accidentally muted myself.
Mm-hmm.
So today we are going to discuss what is reverse engineering in general. I would like to talk about the phases of IT project, which we usually pass through when we are developing some new project. And the phases of IT project when reverse engineering is involved, and how it helps me and our company to achieve better results. So
Maybe
about
time, Anton, it will be great to do a polling now, and could you please choose the sum? I just launched the polling, and you can see that we would like to know your knowledge level in the reverse engineering. And could you please click on your level from 1 to 5, where the 1 mark is the minimum and 5 is the maximum. No, it's very interesting. Some of them have the 1, 2, 3, but nobody has 4 and 5. So I hope it will be helpful information in this presentation, and which will be shared with you. Okay, please continue, Anton.
Okay. So reverse engineering and what it is and why it's helpful. Currently, software reverse engineering is often thought to be something which hackers do, but reverse engineering is not limited to using some disassembler or going deep within binary code and spending a lot of time in understanding some low-level stuff. First of all, it's the way of thinking and specific approach to data analysis. So as Institute of Electronic Engineering specifies the reverse engineering as the process of analyzing a subject system to identify the system components and their relationship. So it's the approach of analysis when you are learning stuff by trying to identify the system parts and how they are interacting with each other, which are the dependencies of those components, and try to determine their role, and then go deeper in understanding from the top to the very low parts if you need to. So reverse engineering is about reusing the existing solutions and knowledge and experience. I mean that reverse engineering allows you to get information from the existing projects and reuse it in your own development process in order to solve your problems when you meet something unknown, because most of the things were already created by some other people, and you just need to look at them and use their experience. I'm working in IT about 18 years, and 16 years of them I'm doing reverse engineering tasks. So usually people start as developers, and then they become development leaders or project managers. But in my case, I grew to development leader from a reverse engineer. So I worked at various projects where amount of reverse engineering varied from 10 to about 90%. So I mean that there were projects which were totally built around some reverse engineered algorithm, API, network protocol, or file format. And it's not something uncommon. People use it a lot to create their projects for compatibility with some other projects. For example, if you want to support the format which is generated by some proprietary software and you have no way to obtain the specification for it, it is possible to use reverse engineering to determine how to work with this file and create your own parser or even generator code which will allow you to work with this file. And so there were multiple projects where reverse engineering was used as a tool to implement some unusual feature or to solve some persistent bugs which cannot be resolved by using the default tools which developers actually use. And reverse engineering was also used a lot in the software development history. For example, Samba protocol support in Linux was implemented only because of reverse engineering of Windows. So they had to reverse engineer the protocol which Windows uses for file sharing in order to implement file sharing support in Linux. And reverse engineering also is the only way to do vulnerability research or penetration testing. Because, for example, if you do fuzzing, it's the technique of generating specific inputs to check if the application processes the input data properly in all possible combinations. Fuzzing cannot be done without reverse engineering if you are working with some third-party library which you don't have documentation for. So reverse engineering helps a lot to gain the knowledge which you need to make the informed decision. So if you are asked to implement something which you didn't do, you may use information about the existing solutions of this type in order to make informed decisions, because you are using someone else's experience, and it's better than try to guess how much time it takes, how much code must be implemented, how much people should be involved. So reverse engineering is the good way to compensate the lack of knowledge in some area in a short term. Yes, it's not making you an expert, but it allows you to learn something very quick. So are there any questions, or should I go further?
No, we don't have questions, so we are waiting for your slide with the questions.
Okay. So in order to understand where reverse engineering can help you in the implementation of the project, we should go briefly through the project phases, and I'll give you the example on how reverse engineering can be applied there. And so we have here the basic phases of the IT project. Someone said that there is 6, someone said that there is 5. I prefer to use those 5, and in real time it can be even 3. The names is not something canonical, it's just like I remember it. So it's initiation phase, where we decide if we want to implement the project at all, if it can be done, if it's feasible. At definition phase, we specify what we want to achieve, the functional requirements, the limitation. The design phase, it's where we do the detailed planning, where we create the architecture, we draw the mockups and diagrams. And then the development or implementation phase starts, where actually all the code is implemented, the testing is done, and the release is made. After that, there may be a follow-up or support phase where customer bugs are fixed, and this can be the end for the project, or it can be the start of the second cycle of implementation for the new release. So let's start from initiation phase and how reverse engineering can be applied there. So at analysis of feasibility, we ask the following question. Is there any project which does something similar? We often tasked to do some so-called pre-sale researches, where people ask us if it's possible to do what they ask. So we checked at first our own projects to see if we had already a similar experience, and if there is something in the world which did what the customer asked us. And we look at how big the solution for this problem can be. Then when determining the project boundaries, the question which is asked from reverse engineers is which are the limitation of the existing solutions. And at this point, we are looking at the existing solutions and see if they have some limitation, and try to understand why the existing solutions have such limitation. For example, if there is some application, it's mobile application, for example, which does something which a customer asked us, and it only exists for Android. The, the question which is raised is why it's only for Android. Is there some limitation on the hardware, or maybe it's some services which are not available for iOS? Maybe Apple has some policy which limits you on using some feature which is available for Android. So we are trying to understand why such feature cannot be implemented, or is there a reason? Not just try to invent something because people asked it. If there is existing solution and people had problems and they couldn't implement it for iOS, there was a reason, and we need to know it beforehand, before the project really started, so that the expectation for the customers are set properly.
Anton, can you tell that using reverse engineering, it will be not blue ocean in the initiation phase to start some project? And so this is like competitive analysis, but for technologies, for the features, for the something. So we are able to look inside of the project, yes, of our.
Sure, and I'm going to speak about it in more details after we go to the new phases.
Okay.
Sure, because it's usually what I do, because I can tell about all the people in the company. And when about the selection of the technologies, it can be some of the technologies which the customer asks you to use, or something which you are trying to select yourself. So in this case, the selection of technologies, if it's something new for you, can be done by intuition and the amount of hits in Google, but from my experience, better to research what people use for such tasks. For example, when we were creating a forensic application, it was vital for us to comply with the standards for the timestamps, and we very early understood that there will be a lot of math related to timestamps and time zones, and there must be some way to do it in some standard way. So we have started researching the existing forensic applications to see what they use for this math, and we found that most of the projects use ICU library. So it was for us a good start, the library which allows us to make the accurate timestamps, and we haven't tried to invent our own math. And then we do planning and estimation to understand how much time it may take to implement the customer's request. So we are trying to analyze how much time it took to implement the similar projects. The information can be taken from various sources. Personally, I use information about the open source projects, because it can be seen there how the project evolves, how much code they implemented from one release to another, how much people was working on it. If some project which is related to the domain which you are working with has a good timeline and change log, it's active project, you can actually see how the project evolves, and changelog allows you to see how much time it took them to implement something. So I rely on this information for making the basic estimates. This slide you were asking about.
Yes, but I didn't see for current moment no questions. So guys, everything is clear, and so maybe do you have this functionality, and do you see this question and answer? So could you please check? Anybody can type any question just to check that this functionality works correctly. Guys, could you please type plus in our group chat that no question, but say, oh, thank you. So, Anton, I think you can continue.
Okay, let's go to the next phase.
Okay.
So then the definition phase starts if we agreed to proceed. And at this phase, we are identifying and specifying functional and non-functional requirements. We are trying to understand the design limitation, the dependencies between the components, which should be implemented in the final product, and set the performance constraints. Also, at this phase, we specify the technology stack. So here we select the technologies and write them down for implementation. So with reverse engineering, we continue with our approach. We try to analyze the other projects which have the similar features. So this time we go feature-wise. Not only we are trying to find some similar product, but finding some product which has the feature which the customer asked, because it can be a good source of ideas and understanding which problems such a feature may have. In my case, I had the experience where the customer was obsessed with the idea of creating timeline control for the forensic application, where all the data which is gathered by the application from various sources was displayed in a nice way. And we did a research just to see if any other applications use the timeline view in the forensic domain. And for our surprise, there were none. Usually a forensic application had just a table view where you are shown all the artifacts and you just sort them by date time, and that's it. So it was weird, but the customer insisted so that we continue and implemented this graphic control anyway, and we did it. And when the release happened, it appeared to be a problem. This control cannot be used by the forensic examiners because they have a procedure which they need to pass when they're doing their investigation, and there is no such step which describes working with this timeline. So they cannot use the screenshots of this timeline to provide them in court, so this feature appears to be unusable. So this is a clear example where something must not be implemented because there was a reason for not implementing it. Yet it felt very logical to display the data on timeline, and if you are not forensic investigator, you could look at it and it worked just fine. But it didn't become a competitive advantage. So When identifying the design limitation, we also check again for feature, for each feature, which limitation the feature has. As example, I can say about IDA, the interactive disassembler, which is a favorite tool for the reverse engineers, and it has had no undo feature up to 2019. So this is a common feature for multiple editors, graphic editors. Almost every tool has undo feature, but IDA, which is on the market for about 20 years, haven't had it for decades. So why was it so hard to implement for them? In their case, they started as a disassembler, which showed just the text of the disassembly, and then they decided to make it interactive. And they made it in a way that there was auto-analysis thread, which did the analysis work in the background, and they allowed the user to make changes while auto-analysis thread works in background. And when this work was happening, both user and the auto-analysis thread were adding queries into engine queue, and then engine just executed the queries. So the problem was that they had no way to distinguish the actions which were added by auto-analysis and by user. So when Control-Z was pressed, there was no way to determine if it's the action which user made or if it's auto-analysis which added some new function or created a new name within the disassembler. So in case you are creating something which is interactive and you are trying to do some background work, it can be a problem for you to create a new feature because some of the projects face this. And then we are going to specification of technology stack. So here we ask again, what is the common way to implement such requirements? What people usually use for such projects? So if you are going to create a firewall for Windows OS and you try to analyze the existing solution, you are going to see that they all are made in a similar manner. So they consist of kernel driver, Windows service, and UI process. The driver is used to intercept the traffic. The service is used to configure and control the driver, and this scheme allows to minimize the possibility of malware to tamper the configuration of the firewall. And you have UI process, which shows the events, which shows some rules which are applied now. So this is a stable, good way to solve the firewall projects. And if you need to implement your own firewall, which must not be something really inventive, next gen, and so on, you just use it as a starting point and then try to improve it. It's a good way to do something by reusing someone else's experience. Also, there can be a researching of performance constraints or domain-specific research, and maybe some planning and estimation is required here to be more detailed for the further steps. Researching the performance constraints doesn't require a lot of reverse engineering, but in case you want to assess which exact part of the application takes some time to do specific work, you may use reverse engineering approach to understand how the competitive solutions are doing it. If they are using a multi-threaded approach, if they are using I/O resources to the limit, you can make this data useful for you to understand which performance can be achieved. So there are applications which are doing some work at this speed, and they process such amount of files, and this is your baseline. And domain-specific research may be required in case you are working with something specific to some domain, like medical equipment or embedded engineering or forensics, as I do, or some antivirus may require you to learn about the things which are valuable for such projects, and by learning how the existing solutions work, you may get this information. And when planning or making the estimates, you can go feature-wise to see how the same features were implemented in the other projects, and get your own idea for how long it may take with your team, depending on the speed, how your team works, so how many people you have, and so on. Any questions for now?
Yes. We have a question, I have a question, and could you please explain us according to estimation process, how many time does reverse engineering take for the different type of projects? Just to like approximately, and for such type of project, yeah, and it can take such.
Reverse engineering highly depends on the amount of tools which are available for the platform. It also depends on the quality of the code, because some of the code can be really obfuscated, the string information encrypted, all the debugging symbols are stripped away so that you have pure instructions and nothing else. Or there can be really good target for reverse engineering when you have even a decompiler which you run and see the code very clearly from the very beginning. So it depends from the beginning when we start. So at first we start to analyze the binaries which we are going to reverse engineer, and then we make the decision. If you would like to hear how much time it takes usually, so quick reverse engineering projects are taking about a week or two, but we had a long-term reverse engineering projects which were about vulnerability research, which took several years, because we had to find all the vulnerable part of the big application, and it took us 2.5 years, as I remember.
Okay, and other question related to, I think, with the first question is reverse engineering suitable for all type of projects, software and platforms, so or not? Or we have some exceptions for the reverse engineering, some cases where we cannot apply reverse engineering skills.
Well, I would say that reverse engineering can be applied everywhere where you have the access to the code. So in case you have some embedded solution where you have the PCB which is sealed by some amount of specific
What?
the compound, yeah, I forgot the word. It's sealed with a compound, and you just cannot get to the PCB chips to see what's inside, and this is, I think, the only way where you are limited in working as a reverse engineer. You can only guess and do black box analysis, and they can be some web application where you have a client, but you have no access to server code. In this situation, you also just don't have the binary to work with, or some scripts or something.
Okay, Anton, we have the curious question, and we will be ready for this question related to if it is legal.
Oh, yeah.
To do reverse engineering, and because a lot of software have the license and they have some statement in this agreement, and so this is property, and we are not able to reverse the some soft.
So different countries have various laws about those reverse engineering cases, and in US, as I know, there was a case where Google reverse engineered something from Microsoft, and Google won this case. So the generic rule is not to implement as is and do not do full copy of the existing solution. So it's so-called clean room reverse engineering approach, when you are reverse engineering something to learn how it works, and then you create your own. In such case, it's okay to do. But if you just learn how to use someone else's technology and take it as is and embed in your own project, this will be prosecuted. In case of our firm, we have a department with the lawyers, which have their job to analyze the customer queries to see if it can be reverse engineered or not.
Yeah, because really in our experience, we have the cases when we have requests from some guys who would like to just crack some game, for example, and to be able to provide some functionality, additional functionality to avoid the main functionality. I don't know, maybe to be winner in this game, or probably to add some, I don't know, some special features. But of course, we are rejecting such requests, and so we would like to follow the legal rules. For this moment, we don't have any additional questions, so please continue.
Okay. Okay, so we are going into design phase, and here we are starting to create the prototypes. We are making the mock-ups, the sketches or diagrams for the architecture, and we are assessing the resources which we have and trying to finalize the plan of the implementation. And so when creating a prototype, reverse engineering helps a lot to solve the implementation issues, which often arise because you are starting to work with a new technology, and often you work with some third party which comes undocumented or just has a library file as a binary and the header where the function definitions are, and no comments at all, and you are trying to ask other people about this library and you have no answer. So Stack Overflow doesn't help you at all. So in my case, this was happening quite often because when we worked with the embedded development, often some third-party library should be used, and it's very poorly documented, and guessing how to use it took a lot of time and effort in order to make something which you plan to do. So analyzing the similar projects which actually use such library can be really helpful, and you can see how they pass the parameters, how they initialize data before calling some function, which callbacks you need, if it can be used from multiple threads, and so on. So at mockup design, it also helps when you are looking at someone else's existing solution to see how they did it, especially if it's something which you never did before. In my experience, I had the situation where I was tasked to create the secure updater for the antivirus, and it was the task which I never did before. So I went reverse engineering the existing updaters for various software to understand which features I actually need for the updater, which of them can be done securely, because antivirus demands that updating phase should not make the computer exposed to the viruses while the antivirus is updating. So after the analysis of existing solutions, I made my own architecture of how I will do the updates, how the patches will be applied, and so on. And when the resource and finalization of the plan happens, you also may ask a question: how many people are there on the similar projects? So, for example, I had a project where I had to implement the simulator for the hardware architecture. So it has to be able to run the binary code for the specific chip of one of the manufacturers. And in my case, I had 3 people, and we did it in 3 months. For example, I did the research of how the similar projects were implemented worldwide. So I found the firm called Lauterbach from Germany. They are professionally implementing the simulators for various platforms. From LinkedIn, I was able to find that they have 16 engineers. 6 of them are just doing the hardware work, and 10 of them are working with software implementation. So after looking at their release cycle at the website of this firm, I found that it took them about a month to add a new CPU. So it's about 10 months to create the support for the new hardware. And for me, it took 9 months. So it's something similar, which is good to know that you are doing in a manner which other people do. And if I had to assess the project of such type, I could use the information which I found on the web. Any more questions for now? Oh, I can hear you, Claudia. You are muted.
Guys, do you have a question? Could you please type this in the group chat or in the question and answer section? And so I have a question according to I have a question according to what is more reasonable proportion between a development team and reverse engineering team for the company, or probably for the development team itself?
From my standpoint, how it will work.
Yes, your vision and.
I prefer to work on the project where it's about 20% of reverse engineering and 80% of implementation. In this way, it's not becoming something really depending on someone else's technology. You have a lot of your own information and knowledge which you use, and those people are just covering the gaps. And in such manner, I think it works the best.
But the question is not the type of activities. I mean, how many people we should to have in the team with reverse engineering skills and with development, like software engineering skills only.
Oh.
What is your recommendation? And so, for example, for 10 engineers, we should have one reverse engineer.
No, I think it's too little. I would prefer about 3 or 4, because when it's a bug fixing phase and a lot of bugs are coming from the customers. So I will talk about this later through the presentation, but in my experience, very good when people are capable themselves to recover the environment of the bug which was poorly described by the user, and he's using crash dump, for example, for this. And reverse engineering helps a lot during the implementation phase.
Okay, so each software engineer should have some reverse engineering skills. So, your opinion?
Each, it's maybe too much, but 3-4 per 10 people, I think it's a nice way where you are able to work with anything.
Okay, we have one more question, but I think I will ask it in the next section.
Okay.
Mm-hmm.
So, implementation phase. We are currently implementing and testing the code, and then we are integrating the project parts. We do the documentation which is necessary for release, and we do the releasing itself. At the implementation and testing phase, it's again all about the third-party libraries which are poorly documented, and you may have a good proof of concepts, but then you are trying to do something more hardcore. You are doing the performance load, and it suddenly start to all fail and crash. So solving complex issues with reverse engineering, when it's a lot of code involved, it's much more easier because you are much more faster in determining which was the exact model which failed. So in my case, I had the project where we had about 90 third-party libraries. About half of them were in binaries, and we had a lot of work to do in case something crashed, to determine who was responsible for this crash, which part of the application must be changed in order to fix it. And often there were such situations where everything worked, but then suddenly something new comes into the callback, which you passed it to third-party library, and you just don't know how you need to react on this. So reverse engineering helps you to find why this happened, what was the reason for this new data to come to your input. So when integrating the project parts, we had also a lot of issues which we need to solve with third-party libraries. For example, I had an issue with Oracle outside-in libraries, which we reported to them, but they say that they are not going to fix them. So we had a crash somewhere deep within the library, which come as binary, and we needed to solve this fast in order to release. And the only way to find why it crashes was reverse engineering, so that we could understand how we can work around on our side. Because the explanation Oracle gave us is just you should use it in the other way, which was not an option for our project. And we couldn't just redo whole architecture when we are months before deadline for the project. And also, if you are working on some driver development, often you have to solve the question of some third-party software to prove that it's not your driver which caused the crash, and it can be something else which is installed on the user's computer. And the only way to see who was the reason of the crash is reverse engineering of the crash dumps. Documenting phase is maybe the only part of the IT project where reverse engineering is not applied, but I had the experience where we had a request on documenting the protocol which was implemented in the firmware of one embedded device. So the whole project was to reverse engineer to see where the protocol handler is, which command it has, and document all these things, provide the documentation. And at the releasing step, we also do the protection of the application. We add some licensing, we are applying some obfuscator, we are doing some anti-debug checks in order to protect the application. And the only way you verify that all this works is reverse engineering. So you protect your own application, then you try to tamper it, change something in it, see if it reacts on everything properly. Because you either rely on the message box which the protector software shows you that everything is protected, or you are not, and you see if it really worked. In my case, I had the project where we implemented obfuscator itself, so I had to reverse engineer the output of obfuscator each time, so it was the only way to develop such type of the project. Otherwise, I just couldn't estimate if or assess if it's protected properly, if the obfuscated code actually was changed in the way I intended it to be. So, any more questions, or I continue?
Yes, we have some common question about the background and what background should the engineer has to make reversing properly.
What do you mean background? The knowledge?
Yeah. I think we have some page, yes, on this presentation related to this question. So probably we can answer.
I don't know if we should go through all the reverse engineering skill because it's a long talk, so I can speak about this briefly. Usually it's understanding of how the system works, how to monitor the data, how to find the place where the feature is implemented. It can be achieved through various ways. Some people start from top-down approach, some from down to top. So someone try to monitor the data, then try to do data flow analysis to see where exactly this input data will be parsed. Some of the people are starting from a disassembler or the compiler. They try to decompile everything, find some place in the code which is related to the feature which they are trying to understand, and then go up to see where the business logic is located. And this is the things that you need to practice. So the tools are just helping you, and it's actually the approach to analyzing the data.
Okay. Thank you. So no other questions, so please continue. And Anton, we already consumed all reserved time, so it's already.
I have one final slide, okay?
Okay, excellent. So.
Okay, so we finally at the fifth phase, follow-up or support. So here we fix bugs reported by the customers and implementing final patches or hot fixes which we want to add into release product. So at the point where we fix the customer bugs, as I said, it's often when the information for the bug is pretty limited. You have some piece of log, maybe some mini dump where just part of the information of the system is stored, and you have to recreate the environment on your computer in order to reproduce and fix the bug. Reverse engineering here is must-have feature. And when implementation of the patches and hot fixes happens, it's usually, for example, in my case, I had the project where it was in support phase, but then the customer wanted us to add some new features into it. And the initial development team was long gone. We had a project with about 10 gigabytes of libraries and source code, and we had to find the place where to put this small feature very fast. So if we would try to analyze all those 10 gigabytes of code just through reading the source code and looking through the architecture, it would take us a lot of time. And through reverse engineering approach, which I used, I was able to find the point to add the new code very fast. So for sometimes the support phase is just the new beginning for the new project. And the question which may raise in your hand, do you really need reverse engineering in your project? What are the risks? So if you build your project around some reverse engineering technology, it still doesn't belong to you. By this, I mean that if you reverse engineered some file format and you are implementing support for it, it doesn't mean that you own this technology and you'll be able to support the new version of this format. because initially some other company implemented this format and they are referred to be as authors. And if they implement the new version which you don't support, you are again at the position when you need to reverse engineer it from the very beginning. So it can be used for creating some compatibility features, but it's still not yours. So when replicating the technology, you get flavor identical to natural. The code which you create based on your research, if you don't try to understand it fully, it's just flavor identical to natural. It's not something which you understand how it works. So there can be consequences somewhere in the future. For example, you implemented some feature which allows you to react on the events when the iPhone is connected and iTunes detected the device. You find some place in the code, you add some hook and you use this hook in order to react on the device behavior. And then with some new update of iTunes, it actually starts to call this hook 3 times in a row. So you don't really understand if this place is good for you, and you try to use something, it will have some consequences which you didn't expect. So you must be very sure about what you use in someone else's technologies. And so incomplete recovery of the logic is the source of the bugs. If you just find some API and you think that it will work for you just because the name of the function looks good, or some of the parameters are usually placed as zeros, and you are okay with that, it doesn't mean that it will not fail. You need the complete understanding of what undocumented API does before you try to use it. There can be a lot of things happening because it's just undocumented stuff. So reverse engineering must be done in a responsible way, when you are not just finding the way to use the feature, but you also understand how exactly it works. In this case, the reverse engineered code may be used. That's it for now. Any more questions?
So guys, the time when you can use the button raise a hand. So if you have some questions, so please click on this button. If everything is clear, so we are ready to hear from your side. Thank you for Anton. Thank you for your time and for this presentation. And anyway, we will share with you this presentation, and we did recording of this webinar. And so the question for you, if it will be interesting for you and you are interested to get this presentation and video of this webinar, could you please type a plus in our group chat if you need this presentation? Probably it will be great to share it with your development team and to discuss internally. Okay. Okay, great. Thank you. Thank you very much. Okay, so we will provide this, probably not today and tomorrow, or maybe the day after tomorrow. But anyway, thank you for your time, to all who found the time for this webinar. It's really great to us to know that our knowledge is interesting for the people and for our target audience and the company who are working with the cyber security. And thank you, Anton, and have a good day, guys. I hope we see you next webinar. Yeah, Anton, are you ready?
Yes, sure.
More detailed technically.
Yeah, so people, you may say the exact topics for the reverse engineering which you would like for me to cover, and I will prepare the presentation for it.
Okay, thank you very much. Yeah, bye-bye.
Bye.
Bye.